this is Alejandra. Welcome to this video where we'll explore three important chemical processes: combustion, electrolysis, and sublimation. Each of these processes play a vital role in our daily life and in various industries. We'll examine what each process entails, its real world application, and the specific conditions required for it to operate efficiently. By understanding these processes, we can better appreciate the science behind the technologies we use every day. Number one, combustion. Combustion is an exothermic chemical reaction that occurs when a fuel such as hydrocarbons reacts with oxidant, typically oxygen. This reaction releases energy in the form of heat and light and produces byproducts such as carbon dioxide and water vapor. Combustion is fundamental to many everyday applications, including transportation, heating, and cooking. Consider the internal combustion engine in cars. It relies on a controlled combustion process to generate power. The engine mixes fuel with air, compresses it, and ignites it, releasing energy that powers the vehicle. For the engine to operate efficiently, precise ratios of fuel and air are necessary, as well as proper temperature and pressure conditions. Variation in these conditions can impact engine performance and emissions. Operating conditions. Temperature. Ignition temperature varies by fuel type. Gasoline ignites at around 280 430 grades centigrade, while natural gas requires over 100 grades. Fuel to oxygen ratio. Methane requires 2 parts of oxygen to complete combustion. Pressure. Combustion efficiency increases under high pressure, which is why turbocharging is used in engines to improve power output. Number 2, electrolysis. Next, let's look at electrolysis. This process uses an electric current to drive a chemical reaction that otherwise wouldn't occur on its own. Electrolysis is crucial in various applications, such as producing hydrogen gas from water, purifying metals, and electroplating. In electrolysis, we use two electrodes placed in an electrolyte solution. The positive electrode or anode attracts negatively charged ions, with the negative electrode or cathode attracts positively charged ions. As the electric current passes through, it causes these ions to gain or lose electrons, resulting in a chemical reaction. For example, when splitting water, hydrogen ions on the cathode gains electrons to form hydrogen gas, while oxygen ions at the anode loses electrons to perform oxygen gas. Electrolysis is a key in industries focused on sustainable energy. Producing hydrogen fuel through water electrolysis is a green alternative to fossil fuels. While the process requires significant energy, recent advances are aiming to make it more efficient and viable as a large-scale energy source. Operating conditions. Voltage. The minimum voltage to split water is 1.23 volts, but actual applications often uses 1.5 to 2 volts for efficiency. Electrolyte. Common electrolytes include sulfuric acid or potassium hydroxide for faster ion movement. Temperature. Higher temperatures reduce resistance and improve efficiency, though most systems operate at ambient temperatures. Our third process is sublimation. Unlike combustion or electrolysis, sublimation is a phase transition where a solid transforms directly into gas without becoming a liquid first. This process is observed in substances like dry ice or frozen carbon dioxide, which vaporizes at room temperature and standard pressure. Sublimation occurs in materials with high vapor pressure and low melting points. When a substance is heated, its molecules gain enough energy to overcome the forces holding them in a solid structure, allowing them to transition directly to the gas phase. This opposite process, where a gas transitions directly to a solid, is called deposition. Sublimation is widely used in the printing industry. For example, in dye sublimation printing, solid dye is heated and transformed into gas, which then permeates the fabric or material surface. This results in vibrant, long-lasting colors. Sublimation is also applied in freeze-drying food when frozen water in the food sublimates under low pressure, preserving the food's structure and nutritional content. Operation conditions: temperature and pressure. Sublimation often requires low pressure and specific temperatures. Heat source. Controlled heat helps maintain the solid above its sublimation temperature for an efficient phase transition. Environment. A controlled low pressure environment is critical in applications like freeze drying and pharmaceutical processing. In summary, we've explored three essential chemical processes and the specific condition required for each. Combustion powers engines and generates heat, while electrolysis drives reactions using green energy and material production. Sublimation, on the other hand, transforms solid directly into gases and is crucial in industry from printing to food preservation. By understanding these conditions that optimize these processes, we can harness their benefits more efficiently, paving the way for innovations in energy, manufacturing, and technology.